Okay, a little bit more factoring practice before we learn a new factoring scheme called the sum or difference of cubes instead of just difference of squares. What do you guys think on that first one? What would be a good way to factor that problem? It's a difference, and there's squarey stuff on both sides, so yes, difference of squares is definitely the way to go. They don't share anything, that wouldn't work. So this is equal to, what's being squared here?
4.
What's being squared to produce?
2x.
Yep. The difference of squares we always have 1 plus, 1 minus, you pick which order. And what's being squared here?
169.
What's being squared to create 169?
84.
That's 13 squared, I'm hoping you guys recognize. Okay. This guy. Can you do difference of squares? It's got a difference. 200 is not a square number, 40 is not a square number, x isn't a square variable, so I'm thinking no. And it's not 3 things, so we shouldn't look at combinations. So what's that leave? We should do these by process of elimination. If it's not difference of squares, it's not a combination standard trinomial problem. It's what they share. What do they share?
40x.
Does 40 go into 200? You might use your calculator. Does 4 go into 20? Yeah, so I think they do share 40. You guys were right. 40 and x, I heard. Good. So if we take 40x out, what's left? Well, divide 200 by 40 and you get 5. We took the x out. Take the 40 out, and one of the x's out leaves one of the x's. There's a minus in the middle, that's factored. Okay? And this one, I think there's a couple ways to do it. Suggestions? Caden?
4-step.
You can do the 4-step process, because a is not equal to 1 here. True, that would work. I'm going to show it a faster way. On this one, you don't have to do that. They share. What? 2. The 2 is the inconvenience part. So if you take it out, that's left, that's left. Oh, no. Took the 2 out. Take 2 out of 198. What is that if you divide? 99 minus, and then let's see, do these factor? There's some multiples of 99. 9 and 11. Is that going to work? 3 and what? 33. Very nice. I don't think that's going to work either. Anything else? You can keep experimenting with your calculator. I don't think anything else is going to work. So as it stands, this would have to stay right here. That's as much as you can factor it. How can we fix this to make it factorable? It's really close. 9 and 11 almost work, don't they?
If it was 2x.
Yeah, if this was a 2x, wouldn't we be set? So if I modify the original problem and make this be a 4x, then we'd have taken 2x out and had 2x left. And then how do we work this? So like that. X, x, -9, +11. Make my negative big. That times that's -99. That plus that is +2. That works. Okay, otherwise we'd have to say not factorable. On your worksheet, just realize I did make them up in my head as I was going, but I'm pretty sure they're all factorable. So they should all pretty much be factorable. If you run into one that's not, come ask me and we'll make sure it's not. Okay? So, in other classes, there's other types of factoring as well. Those are the ones that if you have mastered, the ones we've seen, difference of squares, what they share, looking at the last number, and the 4-step process. If you know how to do those, you'll be good in other classes. But there are other factoring methods as well, so I thought I'd show you a couple other ones. So 2 of them, these guys, for instance, they don't factor by anything we learned so far. Do these share anything? Is it a difference of squares? Is it the last number? It's none of those things. It's totally different. How about that? don't think anything we've learned lets you factor either one of these so far, so we need a new strategy. So there are two new strategies that you can use. There are, if you look at these, some very cubic type things happening. You can see x cubed. What is 8? 2 times 2 times 2 is 8. It's 2 cubed. And over here, 5 times 5 times 5, that's 125. That's obviously cubed. This is also cubed. It's n cubed squared. If you go n cubed squared, power to power says multiply exponents. That's also a cubic thing. Okay? So all of these can be, or these two problems can be factored with what are called the sum or difference of cubes. So, some very good stuff to know for Algebra 2, classes beyond that. So what are the sum or difference of cubes? So the sum of cubes and the difference of cubes. So they're also nice things to remember. They work really close to difference of squares. So I'm going to start with the difference of cubes, which is what we're going to use on the first problem. Okay? So, if you have a difference of cubes, something like, I don't know, x cubed minus something else cubed. How's that factor? Well, difference of squares went like this, right? Went like x minus a, x plus a, right? But this is difference of cubes. It starts out the same. Except if I multiplied x times x, what would I get? X cubed? What would you get?
X squared.
X squared. So what should this be? That times that is x cubed. What do you think the last thing has to be so that when you multiply these two things you get a cubed? How'd Richard decide plus? He seemed pretty confident about that. Negative and a positive makes a negative. Awesome. So there's just one more thing to fill in here, and that you can kind of do from experimentation or memory. I'm just going to tell you today. It is plus x times a. Okay? If you did a little experimenting, you'd find that was what it was, but we're going to do this more quickly. Okay, so sum of squares cannot be factored. It yields, we'll find this year and next year, imaginary numbers. It doesn't have a factorization scheme. Sum of cubes does. It does have a factorization scheme, and it's almost the exact same thing. So I remember one thing for both of these. Watch. In fact, you guys can probably help me out with this a little bit. If this was minus to begin with, what do you guess this is? Yeah, and then what's going to go here if we get x cubed when we distribute?
X squared.
X squared. Here we need a cubed when we distribute?
A squared.
Positive or negative? What do you think?
Positive.
Yep. And the same thing goes here. Except nothing's ever going to cancel out to get this when you do all your distributing, you know what I'm saying? Unless something is negative, and that's this term. That'll make everything else cancel out except for here and here. If you don't believe me, expand that out and you'll see it cancels out and becomes x cubed plus a cubed. You good, Sheridan, or not? Yeah. So to memorize this, it's super simple. You can fill these in, and the only thing I memorize is when it's plus, it starts plus and goes plus minus plus. When it's minus, it starts minus and goes minus plus plus. Each one of them has how many minuses in it? 1. It's very easy to remember if you do it like a couple times. So, and a nice little strategy to factor things like these. So, can you guys help me out? Let's see if we can factor x cubed minus 8. First, you have to do what we've been doing. First, you have to recognize it's a difference of cubes. And it is, because it's a difference. That's clearly cubed. What's being cubed here? 2. So let's write that down above just to remember that it's really 2 being cubed there. And now we're going to factor according to the scheme formula. So we're going to go, all right, bigger for the second factor. Yeah? What goes first? Can you guys help me?
X.
X. Minus or plus? Remember, minus starts minus. 2, good. And then we go x squared and 2 squared, right? So it's 4. Minus or plus here?
Plus.
Plus. You can either look directly at the formula or try to remember it and say, well, there's only supposed to be 1 minus, right? So this one's also plus. And what goes in the middle? 2 x. Now, if you don't believe that, which I'm guessing some of you don't believe that at this point, how could you check? How do you say it? It's factored right now. Use the E word. It distributes good or expand. Very good. Let's expand and see if this actually worked, okay? Just to check ourselves. So that's done. That's all you guys need to do. But I'd encourage you to check yourself a couple times. Here we go. X cubed, 2x squared, 4x. The next one's in green. Minus 2x squared, minus 4x, minus 8. You're going to have to do this distributing process on our next big exam anyway, so it's good to check yourself just to remind yourself how to do it. What happened here that's super nice? Cancel. Cancel. Booyah. It worked. Yeah? So this is the difference of cubes. So I think we can factor this one with our other one, the sum of cubes. Let's kind of come down here a little bit. Give ourselves some space. So can you guys tell me what is being cubed here?
5.
We talked about it. It was 5 and m all being cubed, right? And what was being cubed here? You can do it as n squared cubed or n cubed squared. Why do we write it this way?
Because we need it cubed.
Because we need it cubed so that it follows that formula. Okay? Now we just fill it in. So we go, right? Small factor, big factor. And I think we went first thing plus second thing. Right? And then you guys help me over here. What do we have to do according to the formula?
5m squared.
5m all squared. So what's that going to be? 25m squared. Careful, that 25 thing, that's going to get you. And that's in like all the math that we do from here on out, that issue right there of having to square it all. So get it down now and it's not going to ever be a hindrance to you ever again. I think we then have a minus, right? And then we have x. X is, remember, just the first thing, so we've got a 5m. Then we have an a, which is the second thing, which is n squared. And then we had a, the second thing, squared. So what is it going to be here, the second thing squared? It's going to be n to the 4th. Very nice. So plus, minus, plus. Done. Now, if you don't believe that, which I know some of you don't, distribute and see if it's actually equal to 125m cubed plus n to the 6th. That would be a great exercise to distribute that. So if you're watching the video, I'd highly recommend distributing that and seeing what you get.